Okay, well, good morning and happy Friday. Um, I am waiting to hear back from Data Camp. I know a lot of you are have questions about Data Camp and the Data Camp homework, and I sent in an application to get the data camp licenses for this classroom or for the class and get everything set up, but I haven't heard back from them. So um, I hope it goes through and I hope I'm able to get everything approved, but I apologize for the delay. So just for now, just sit tight and as soon as I hear from them, I will let you guys know. But right now, they haven't responded and their website changed a tiny bit regarding the DataCamp applications. And so, I'm hoping things are still working and things are going through, but I don't know. I'm not quite sure what's going on. Um, okay, let's take a look at a little bit more on data visualization. We introduced ggplot on Wednesday, and today I wanted to just kind of do work through a couple examples of using data visualization as a way to kind of explore data and just start to begin to even ask questions or begin to just look for interesting relationships that could exist in the data. Okay, so um, we're going to take a look at chapter 2 from Modern Data Science with R. This kind of introduces some of the stuff. And then in the homework, I think one of the exercises in the homework says, find a data graphic that's compelling and find another data graphic that's not compelling. And so one place where there is both good and bad data graphics and things where just people just kind of share data graphics is this subreddit called Data is Beautiful. And sometimes there truly are things that are beautiful, and then sometimes there's just things that they try to present data and it just doesn't quite work. And so, take a look and see what's out there, and you can read some of the comments, and well, a lot of the comments are about the data itself. But sometimes the comments might be on like, okay, why this graphic does or does not work. Okay. Um, and data visualization is one of the tools that we have, but this quote that talks about, why it's so useful is that it provides, an accessible and sometimes compelling and expressive way to kind of investigate and depict patterns in the data. And so here's just a example data set where I searched for Volkswagen Jettas, used ones, and I just gathered some information on used cars. And so we got some cars made in 2019 and 2020. And I just wanted to see, what's the relationship between the mileage, how many miles have been driven on the car, and what the sale price is. And then there's a few different kind of trim lines. And looking at this, do any of these kind of observations stand out? It's difficult to answer this question looking just at the numbers directly. However, if you plot them, okay, and so we can plot them using ggplot, and I can say, all right, let's put mileage on the x-axis, price on the y-axis. We'll color them by year, and we have in our data set 2019 cars in 2019, cars from 2020, and then the trim line, whether it was the S or the R line or the SE or things like that, we can kind of do that. And this is what we see. We see overall, as there's more mileage, the price seems to decrease. Okay. Um, we notice, so in general, the 2019 cars have a little bit more mileage. The 2020 cars, there's actually, a lot of these cars have only a few miles driven on them. But yeah, we see this overall trend where more mileage driven, lower price. Except there's this kind of one outlier which has relatively high mileage driven on it, but it still has a relatively high price. Okay. And if I swap the colors and the trim, if I swap year and trim for colors and shape, we notice there's a little bit of a pattern here. And so here I said, okay, let's color S line in green and then the SE in blue. And so we see there's actually only one SE. And then this one dot, okay, is the only dot that's red, and that is the R line. And the R line is kind of the high performance sporty version. I think it has like extra horsepower and extra kind of features that make it, a bit more of a high performance vehicle. And so this kind of explains why it kind of stands out from everything else. In general, more mileage driven on the car, the price goes down. This one has, relatively high mileage, but still a relatively high price. And that is that we might be able to attribute that to the fact that it's kind of the high performance, the R line for the vehicle. Okay. And so that's the data visualization, this allows us to kind of pick out some of these unusual points, right? When we create a visualization, our brains are able to spot points that stand out. Okay. It would be difficult, I think, a lot harder to pick out, the unusual point just from looking at the numbers. Okay. If you studied them very carefully, you might be able to pick it out and say, oh yeah, you know what, this one is a little bit different from everything else. But I think it's, how different it is kind of difficult to spot. Whereas seeing it in the graphic like this, it's a lot easier to spot why that this point is different, and that's really kind of the power of the data graphics and data visualizations that we're able to kind of see these kinds of relationships. Okay, so the bottom line is we can make data graphics quite easily. Anyone can do it, right? But to make a good one and one that's compelling takes a bit of mastery and knowledge and insight. And and just kind of like anything else, like doing art, making music, playing a sport, some kind of talent, it requires practice, right? And in the beginning, you're going to be creating these things and you're going to feel like, oh, I think I'm doing an okay job. But then as you do this more and more and more, and you look back at your older work, you realize, oh, yeah, you know what? I didn't I've come a long way, right? But in order for you to kind of make that progress where you feel like, okay, I've come a long way where I'm now able to understand what makes a good data graphic and what is good versus kind of like my earlier stuff, it requires you to kind of keep working at it. Okay. Just kind of like, uh, again, playing an instrument, practicing art and things like that, if you look at someone does drawing, okay. In the beginning, their art looks a certain way, and as they make more progress, they gets better and better. And then when you look back at some of the earlier artwork, you go, oh yeah, you know what, they've made a lot of progress, right? Um, we would say a data graphic is compelling if the viewer, the person looking at the data graphic, receives the message that the creator is trying to communicate. Okay. And so these are important things that you need to think about is what is it that you want your data graphic to convey or communicate to the viewer? Okay. Do you want the data graphic to show a general trend or pattern? Do you want the graphic to show a difference between groups? You want the graphic to bring attention to a single unusual point? What is the point that you're trying to make, right? So keep that in mind, right? And to be honest, you might not know what it is you're trying to communicate until you've explored the data yourself, okay? But perhaps you've explored the data, you found this interesting thing, and that is the thing you want to communicate. Okay. And the thing you want to communicate might want to be like, look, this is the one unusual point, right? Like this, here's everybody else. This is kind of the general trend that exists. And look, here's this one person, and look how different they are, right? That might be the thing you're trying to communicate. Or maybe you just want to show the general trend or pattern that exists, okay? Or maybe you want to show that like, okay, this group is quite a bit different from this group in these kinds of ways, right? Once you understand what it is you're trying to communicate, design your graphic around that. Okay, design your graphic around that. This, I know it feels like this is a long way to think ahead, okay? But when it comes to the final project, you're going to have to create a bunch of data graphics and stuff like that. And one thing that I don't know, annoys me or bothers me a little bit is that a student, student groups might find like, okay, here's kind of a neat data graphic, and this is interesting. And then they just take that same data graphic and then they just kind of copy and paste it everywhere. And they just change, okay, instead of this variable, we're going to do this variable. Instead of this variable, we're going to do this variable. And they just kind of change the data, the variable that they're looking at, and you get the same kind of graphic over and over and over again. And maybe there's something interesting there, but they've lost sight of what it is they're trying to communicate. And it's just like, okay, here's a nice, pretty graphic, and let's just make a bunch of copies of it. Okay. Always keep in mind what it is you're trying to bring attention to. Um, and but again, before you can even communicate that message, you might need to explore the data in the first place just to kind of see like what is the interesting thing that exists in the data. And graphics are a great tool for doing data exploration as well. All right, let me give you your first view quiz answer, which, oh, sorry, let me pull that up. Yeah, first letter is the letter A. A as in apple. A as in. Okay, so I'm going to just kind of work through some examples that appear in our textbook. Um, the the textbook explores data from the 2012 federal election cycle, and they gathered data on like um, advertising spending. Okay. And so 2012, this is like, how long ago? That's 13 years ago. Okay. Three presidential elections ago. So in 2012, it was Obama was running for a second term, and the challenger was Mitt Romney. And then there were other kind of elections as well, Senate races and House races and things like that. But that was kind of what was going on. And this was, um, oh, the first view quiz answer, your audio cut out. The letter A, A as in apple. Um, and so we'll take a look at some of this thing. Okay, so yeah, Obama was running for a second term as president. Romney was the challenger. There were different things. We had political action committees, and those they're allowed to kind of spend lots of money on advertisements for or against a particular candidate. And then the Federal Election Commission keeps a log of all kinds of contributions made towards candidates and PACs, and this is just kind of looking at some of that data. I would say the political landscape has changed quite a bit, even just in those few presidential elections since. So I'm trying to think, how old were you guys have been in 2012? Like 8 years old? I don't know. Maybe younger. And in the time since, quite a bit has changed. 2016 was Hillary Clinton versus Trump, and then 2020 was Trump versus Biden, and then 2024 was uh, Kamala Harris versus Trump, and so we have quite a bit of stuff. And anyway, we'll just take a look at this data back from 2012. Okay. Now there was quite a bit of kind of pre-processing work needed to kind of compile the data. The data is available from the Federal Election Commission. A lot of work was needed to be done to combine it. We're not going to worry about that just yet. Right now, we're just going to be looking at like, okay, once this data is compiled and we just kind of want to explore it and visualize it, what kind of what can we do, right? And maybe one of the guiding overall questions that we might have is like, how much money did each candidate raise? Okay. And that might be kind of like the first question that we ask. But this question by itself is a little bit convoluted, okay, or a little bit might not be as meaningful because there's all these kind of weird campaign finance rules and stuff, and there's like different rules about how much an individual can give versus how much a corporation can give. And so, we have all kinds of, weird things going on, like Elon Musk has all of this money and he's spending it, on different kind of elections and stuff these days. And the rules regarding how all of this works is it's a little bit it's a little convoluted, okay? And so one thing what we can do is we can look at just kind of like how much money is being spent on certain advertisements, and we can think about, is that advertisement for a candidate or against a candidate? And we can say, all right, how much money was spent on each candidate? So that might be a little bit of a better question versus how much money did each candidate raise? Okay. And so we'll look at candidates on whom at least $10 million was spent. Okay. And so we have Mitt Romney, Paul Ryan, we have Barack Obama. So yeah, Mitt Romney was the presidential candidate. His running mate was Paul Ryan. So these are the things. We have other people: Richard Murdoch, Josh Mandel, Tim Kaine, George Allen, Tommy Thompson. Tim Kaine was, I think, running for Senate in Virginia. He ended up being the vice presidential candidate in 2016. These were other people that where money was spent. Okay. And so it says, how much money was spent on a candidate? And this looks like, okay, a lot of money was spent on Barack Obama. And, there's also, so that was like what, 260, 70 million on there versus 100 million on Mitt Romney. Okay. But this picture doesn't tell the whole picture. Okay. So, yeah, what does this plot tell us? Most of the spending was on Barack Obama. The second most amount of spending was Romney Ryan, and that kind of makes sense because those are the candidates running for president. Some other candidates in the graphic, you can kind of look these up, and these were Senate election races, and so the Senate is usually a little bit higher stakes than the House because senators serve 6 terms, and these were races in Wisconsin, Indiana, Ohio, and Virginia and stuff. So does this mean Obama raised the most money because this was the most amount that a lot of money was spent on Obama? And that doesn't tell the whole picture because when we talk about spending on a candidate, there is spending that is for that candidate, like supporting the candidate, and spending that is okay, against the candidate. And, living in California, we don't see a ton of political advertisements. Okay, maybe we see some advertisements for, certain, Senate or House races or certain propositions and things like that. But if you live in kind of a swing state, then you get bombarded with with advertisements. And a lot of the advertisements are negative advertisements, okay? It's a lot of so and so did this, so and so supported this, so and so has betrayed America and all kinds of negative stuff. And so if you actually look at the spending, okay, that was spent on Barack Obama and spending on Paul Ryan, there was actually a ton of ad money spent on advertisements that were against Barack Obama here. Okay, so if you look at, right, looking only at just the total amount spent, it feels like, oh, Barack Obama had a lot of money. But what's actually going on, if you look at this picture, is if you further divide it into how much was for or against, you see there was a ton of spending against Barack Obama, against, you know, people trying to, I guess, prevent him from winning a second term. And so uh, it's important that we take a look at, different kind of variables within, not just the numbers, but also just like it's important to check out different splits, how, whether it was for or against. And so this is one of those things there. Okay. So what we see is most of the spending on a candidate is actually against a candidate. We can see as far as uh, also for Romney Ryan, it's mostly red. Barack Obama, mostly red. Okay. And actually, even all of these things, all of these bars are mostly red. Okay. There's a lot of kind of negative political advertising. Okay. Um, More total spending on Obama than Romney Ryan. And if you look at kind of the percentage of spending against, okay, it turns out it was 92% of this. This is only 8%. 92% of the total spending on Obama was against it, versus for Romney Ryan, it was about 70%. Okay. And so looking at the type of spending, whether it was for or against, reveals a lot of kind of important insight regarding the data. Okay. Another kind of question, did Republicans spend more money than Democrats during the election? That might be a question that we ask. And so we can just create a graphic that shows total spending, and we'll look at colored by supporting or against on each kind of political party. Okay. And so here, there are different political parties. We got the Democratic Party, the Republican. What was DFL? DFL is the Democratic Farmer Labor Party. Okay. And then some other thing. Okay. And so we can see like how much money was spent anti-Democratic Party and then supporting Republican candidates. So we wanted to kind of look at the total amount spent by, assuming Republicans spend money pro-Republican and anti-Democrat, and assuming Democrats spend money pro-Democrat and anti-Republican, we can see, all right, the total for supporting Republican and anti-Democrat is, a lot higher than that for supporting Democrats and anti-Republican, at least in the 2012 election. Okay. And so we see, there was more spending supporting Republican candidates than there was for spending supporting Democratic candidates. We can see the blue part here is high for the Republicans is higher than the blue part for Democrats. We can see that there was more spending against Democratic candidates than there was against spending against Republican. We can see the red part for against Democratic candidates is larger than the spending against Republican candidates. That red part is a little smaller. And so we can say, Republicans had spent more money than Democrats during that election. And then, very little money spent on other political parties. That's what we have there. Okay. Um, Other things that we can take a look at to explore is maybe we will break up the spending based on which office. Okay. And so in the 2012 election, it was a presidential election year, and certainly that is, the most important elected official. And so the office of president dominated the election cycle. Okay. So here we have the House candidates, all of the House of Representatives, P for president, S for Senate. Okay. And so we could see, this is like all Democratic candidates, all Republican candidates. And here we can see, when it comes to uh, the spending, okay, for and against, we can see there was so much money spent anti the Democratic presidential candidate, right? There's a lot of money spent against Barack Obama. Um, and a little bit money spent towards supporting, okay, a little bit of money spent towards supporting um, Romney and Ryan and some money's spent anti, but we can see, there's a lot here. Okay. We look at the Senate races, okay, and we see, oh, there's actually quite a bit of money spent against Republican Senate candidates. There was some money supporting it. There's some money spent anti Democratic Senate candidates, and some spent for. But the difference isn't as dramatic as it was for the presidential candidate. Okay, and if you look at the size of these bars, like this red bar and this red bar, kind of similar. This one's a little bit bigger. But yeah, as far as House races and Senate races, kind of the split between if you look at the House races, the amount spent supporting and anti, it's like fairly evenly split. Okay. Same thing for Democratic or Republican candidates. A lot of, for House races, these are kind of like n names that are not as well known. And so there's a lot of kind of like, we just need to get our name out there. Okay. Versus like the president, those names are already pretty well known. And so you don't really need to get your name out there. It's just you're trying to get people to not vote for your opponent or something like that. So we see, the amount of spending changes quite a bit regarding in with regards to which type of office is being sought out, president versus Senate versus House, and things like that. Okay, so we can see overall more money was spent supporting Republican candidates versus Democratic ones. The spending against the Democratic candidate, Obama, was far greater than the spending against the Republican Romney and Ryan. For House and Senate races, money spent against Republican candidates was slightly more than the money spent against Democratic candidates. A little bit more, but certainly not as dramatic there. Okay. Um, Another kind of discussion that existed in 2012 and still exists today is who supports Republican candidates, who supports Democratic ones, and is it just like you have some very few rich Republican donors supporting the Republican candidates, right? There's kind of a narrative that exists that like certain parties appeal to the billionaire classes, and they're trying to get money and things like that. Versus other candidates have support from grassroots support across the economic spectrum, that you have a lot of people with not a ton of income still kind of supporting certain candidates. And so, we can create a plot that shows how many donations were received based on the amount of the donation. And the initial plot here, you can see like um, donations made towards Obama and donations made towards Romney. And when you do this, the donation amount can go anywhere from zero to like 100,000 or things like that, 0 to 100,000. And we see, okay, there's a few things that, pretty much the column at zero is super tall, and the column next to zero is the next tallest, and then you have very few values way out here. It's really hard to see. So this kind of scale where you're going where you have things spaced out linearly, that is the distance from 0 to 25,000 is the same distance as from 25 to 50,000, 50,000 to 75, 75 to 100,000, right? We're incrementing by 25,000, and that's basically like 1 inch every time. That kind of scale might not work super well. So we might have to change how the x-axis is displayed. Okay. So, both candidates have a ton of smaller donations, just a few hundred, few $1,000, and some very large donations make the x-axis difficult to read. And then, plotting this side by side also makes it difficult to compare. So what we can do is we can do a logarithmic scale on the x-axis, okay? And so rather than saying, okay, every time we move 1 inch to the right, we're going to add $25,000, okay, which is what we're doing here. We go 1 inch to the right, you add 25,000, 1 inch to the right, add 25,000. We're going to say every time we go to the right, okay, if I go right to here, we're going to multiply by 100. Okay, so rather than adding, we multiply. That's a logarithmic scale. We're multiplying. So when you go from 10 to every kind of like 1 inch to the right, okay, every line here, we're basically multiplying by 10. So here we're going from 10 multiplied by 10 to 100. We go from 1 inch to the right, we multiply it by another 10, so we're multiplying by another 10. So we go 10 to 100, 100 to 1,000, 1,000 to 10,000, and 10,000 to 100,000. Okay? And then we will overlay uh, the things on top of each other. So rather than side by side, they're going to be overlaid on top of each other. Okay? And we have Obama in red and Romney in this teal color. And then we have yeah, we kind of smoothed out the what do you call it? The drawings or the bins. Okay, so rather than histograms and just kind of bars, we'll have these kind of pointy lines. And so what we see is that this is around 100, and I guess this, I don't know, what is this? This is around probably 200, and this would be probably around 500, and this is probably around 1,000. That would be my guess. So we have quite a few donations of around 200 and 500 and around 1,000. And we just kind of eyeballing, and we have these kind of distinct peaks here. This is probably 2,000, 5,000, 10,000, and then maybe 50,000. Yeah, we see a much higher peak around 200 for Obama versus Romney, whereas, for Romney, we have quite a few more donations that were around 2,000 than Obama had for around 2,000. Okay. Um, and so, the Obama line has much higher peaks, kind of 1,000 below. And then as far as the Romney line, the line is much taller, for above 1,000. Okay, so, does it really support that narrative? Okay, um, a little bit, right? Indeed, it does appear Romney had fewer donations under $1,000 versus donations that were larger. Okay, donations above $1,000. Romney had more donations above 1,000, fewer donations under 1,000 compared to Obama. Um, this is probably a donation of $100, maybe donations of like 50 and 40 and $20 or something like that. Okay. So, even looking at this low end, you have, not a ton, but, as far as donations to Obama, you have more donations, between 10 and $100 versus, according to this, there were very few donations between 10 and $100 for Romney. Okay. If you look at data based on the phase of the election, the difference kind of goes away in the general election. So if you look at the general election versus the primary, okay, so right in U.S. presidential elections, we have there's a few different phases. So the first phase, you have um, the primary where people are trying to pick the candidate who's going to be running for or against, running for the office, and so who's going to run for president, and I don't know if anybody actually tried to run against Obama during the primary, so I'm not sure. This is just kind of like early on, and we have that distinction between donations here. And so these are candidates who really wanted Romney to win the Republican nomination versus, I don't remember who were some of the other candidates that were running for the Republican nomination. There was like Huckabee and I don't know. There were different candidates out there. Um, and so it does seem like Romney had support there. But then when you look at the general election, this is like when it's Obama versus Romney, we see, the trend is actually very similar. You have kind of similar spikes around 200, 500, 1,000, $2,000. Very kind of similar shape for both Obama and Romney during the general election. Still kind of regarding donations of 100 or less, Obama had more donations there, but still just not a ton. Neither candidate had a ton there. Um, how many view quiz answers have I given you? Just one so far? Let me give you your second view quiz answer. Second view quiz answer is E. E as an elephant. E as an elephant is your second view quiz answer. Okay, so these are, again, just visualizations and that we just to kind of illustrate the idea of exploring your data and really kind of just asking questions and just saying like, okay, if we remember, we just started off kind of in the beginning and we just looked at like one variable and it looks like it's telling like a lot of money is spent on Obama. But um, every time we just kind of dig down a little bit more and we say, okay, well, what if we split it by money for or against? Okay, what if we look at the office or the party and things like that. And every time we ask a question, we use kind of a data visualization to kind of explore that thing. And that's an important process of data analysis and data exploration is you ask a question and then you try to create a graphic that answers that question. And then once you find something that seems kind of interesting or neat, then you ask yourself, is this something I want to communicate to my viewers? And if it is something I want to communicate to my viewers, what is the best way to go about it? Okay. Um, we talked about, we introduced ggplot a little bit on Wednesday. And I just want to kind of mention a few other things as far as composing data graphics here. And we already talked about the grammar of graphics of how we map properties of the data to visual properties of the graphic. And these are just a few more of the kind of visual cues that we can use to map out data properties. So one is the position, all right, and we often use that for numeric values. And where is it in relation to other things? Is it higher? Okay, and you can have vertical position higher versus lower. But you could also have horizontal position where things going to the right is generally higher and things going to the left is generally uh, less, right? The length, okay, is, how big or how much. So if you're thinking about a bar, that length or the height of the bar, okay, is going to tell you like how big, right? And so, when we're looking at these bars here, we're really just looking at the length, okay? And we're saying, okay, well, this bar is bigger. And so that corresponds to more spending, okay, more money spent. Um, and that's one thing we can kind of look at. Okay. You can also have an angle regarding, certain lines or certain arrows can point in certain directions. And that can answer questions like, how wide or is it parallel to something else? Um, you can plot a line and the direction of that line can tell us, like what is the slope? Is it increasing steeply or decreasing or things like that? If we're looking at a series over time, is it going up or down? Um, we can plot shapes, triangles versus squares versus um, circles, okay? And that will tell us about what kind of group it belongs to. Um, but we can also use the color, okay? And the color can be, what which group, but also, to what extent or how severely, like how bright or how dark. The shade can also be used to, is it bright or dark for kind of how intense or how severely. You can also change the size of the dot, right? Most of my plots, the dots have all been the same size, but you can change the size of the dot or the thing to be either bigger to indicate like a big group or something smaller. And in some cases, you might even try a three-dimensional thing where you're going to show like a larger volume or something smaller like that. So these are just some of the visual cues that are available at our disposal, and certainly there's many different kinds of plots, and we'll explore them in the coming weeks. Okay. Um, just a few things to keep in mind, again, as you're trying to think, what is it that I want to communicate? Okay, so one thing is people are really good at distinguishing between different heights and different positions, but we're not good at distinguishing different angles, and we're not good at distinguishing between, subtle differences in shades. Okay, so when you look at bars like this, okay, these two bars are pretty similar, but we can distinguish them quite easily, right? Even like this bar in the blue, they're very similar in height, but we can see this one is just a little bit taller than this one, right? Our eyes are really good at telling those things apart. Okay. Other things though, like if you had to kind of measure proportions and they say like, all right, which proportion is that's a lot more difficult. So direct relationships, and I don't have things with the different shades or different angles, but that's a lot kind of a lot trickier is figuring out, different angles here, right? So for example, if I were to plot, if you have pie chart and you have this angle and here's another pie chart and you have this angle or something like that, it's difficult to tell, which which angle is bigger, right? These things are a lot harder to tell. Okay. And so angles are a lot kind of tougher, right? Different shades also pretty tough. So, how can we plot things positionally? We're often accustomed to just a simple coordinate Cartesian system where you have X going horizontally, Y going vertically. But you can also have things, like polar, where things go around and you have distance. Those are different ways to kind of plot things. Um, we can also plot things on a map, okay, geographically. And so certainly certain things we're accustomed to seeing a map of the Earth, and and you might want to plot information about, like, say, countries or things like that on a geographic setting, and that might be fine. But then you have to be careful when you measure distances on the Earth. The shortest line between two things on the surface, when you lay them flat on the map, they look at like these curved lines and stuff. Okay. Scales, things to think about. We can have linear scales where every time you move 1 inch over to the right, you're adding the same amount. You're adding 1,000 every inch you move to the right. Or it could be logarithmic, where every inch you move to the right, you're multiplying. You're multiplying by a factor of 10. And that's what we saw here, right? So here, every inch we move to the right, we're multiplying by a factor of 10. Over here, this one is linear. Every inch we move to the right, we're adding 25,000. So that's a linear versus a logarithmic scale. Um, some things have no ordering. Some things do have ordering. So with like categorical variables, like colors don't have a natural ordering. You could have like red, green, blue, or do you put it red, blue, green? Where do you put the color silver or black in that lineup, right? So there's no set ordering. But other things, other categorical variables do have a natural ordering. Small, medium, large. That's the ordering you would expect it, right? It would be annoying if you if the sizes were put in alphabetical order and it's like large, medium, small, extra large, right? That would be annoying if the sizes were put in alphabetical order versus, the order that you expect, right? Frequency things, never, rarely, sometimes, always, that has a certain order, okay? Time is weird, okay? Time, like when you think of a calendar date, right? April 4th, 2025, you don't think of it as being numeric, but it is numeric. Okay. Our calendar measures basically how many days or how much time has passed from an arbitrary moment in time. So our calendar system is kind of based off of like there's a religious significance, the like Jesus is like birth is kind of set as like the year one or zero, and every revolution of the Earth around the sun is like 365 days ish. Okay. And so we use that as kind of our arbitrary uh, system to keep track of days. Okay. And then we just have this really, really arbitrary system for like like what month is it? And we just have to kind of learn that like certain months have 31 days and other months have 30 days. But really, it's just how much time has passed from some arbitrary point in history. And therefore, like when you go to like other cultures, other civilizations, and you look at their calendars, they have their calendar system might be based on like who was the king or the emperor during that time. And they'll say like in the year of King whoever, in the fifth year of their reign or something like that, right? That might be their calendar system. And it's just kind of like today we just kind of have this arbitrary system where we say, all right, okay, it's 2025 years from this point in time. And but it's numeric because we can do numeric comparisons. We could say this person was born 7 days before another person. This event took place, 458 days before another. And that might translate to like 1 year and a couple months and things like that. Okay. Um, we talked about this, the use of legends and labels and tick marks and axes, that's very important. Um, Sometimes you want to show a bunch of different variables, and there's a few different ways you can do this. One is you can have facets. Facets are basically multiple graphs of the same kind of thing split up by different variables. So for example, this is the same graph, but we have it faceted based on whether it was the House race, presidential race, or the Senate race. So it's the same graph, but we have it. We say it's been faceted. Okay. This is also same graph, but it's been faceted based on the candidate. So that's one way we can show different kind of things. Another is we can show layers. Okay, so here is layers where we have basically the blue layer overlaid on top of the red layer to kind of show our different candidates. Okay, so those are different ways we can show different variables. Okay, and then you can even do animations. And I don't have animations in this example set of slides, but that can show how things have changed over time. Okay, I'm running out of time. As far as colors go, there's a few different tools and you can just arbitrarily pick colors. You can have a gradient of colors. And anyway, we'll just kind of wrap things up here. This section talks about dissecting graphics, and this is also covered in the textbook. So I encourage you to look at that. The one thing I do want to kind of point out, though, is the importance of data graphics, and I'm going to just kind of skip to this, is in the 80s, there was a space shuttle disaster. The Challenger space shuttle exploded, and it was caused by a failure of this O-ring sealer, and that became brittle in the cold weather. Here, let me go ahead and give you your last view quiz answer. Last view quiz answer today is the letter B. B as in bear is your last view quiz answer. And in the cold weather, the O-ring became brittle and it failed and it exploded. And this was how the data was presented, okay, or was kept track of, and these show kind of like the different failures and things like that. And this data is difficult to make sense of. There's like different temperatures written on here. There's indications of failures and stuff like that, but it's difficult to kind of see, right? Make sense of this. This data presented here, hard to understand. Okay. Also presented like this. Okay, difficult to understand. Here's a data graphic. This shows the temperature at which the launch took place and how much damage is shown on the vertical axis. Okay. And so now we start to see a trend that at higher temperatures, very little damage, at lower temperatures, a lot more damage. Okay. And this graph shows how cold it was the morning of the space shuttle disaster. Okay. So all of the other launches up to that point took place, in much higher temperatures, 60 degrees and higher. There were a few launches under 60 degrees, and we can see like when it was around 50 degrees, there was much higher damage. And then on the morning of the space shuttle disaster, the launch was in the 30 degrees. Okay. It was around, or actually 26 to 29 degrees. And so, we don't like to extrapolate, but we can see how much colder it was that morning versus everything else, and that it would have been quite a risk, okay, to, if you extrapolated, you'd see, okay, the amount of damage could be quite severe or something. And it turned out to be very severe that morning, in that it failed and it caused the space shuttle to explode. So um, when the data is presented in ways that are difficult to interpret, the important message is lost. Okay. And and so again, what is it that you're trying to communicate? If there was an engineer who was aware that there were problems when it got cold, okay, but that engineer was ignored, and I don't know what data graphic was being used, but that problem, whatever it was, wasn't properly addressed. Okay. And perhaps a data graphic could have shown, you know, um, exactly how much of a risk they were undertaking by taking, launching the space shuttle in such cold weather versus everything else. So anyway, this is just kind of something to point out. Um, read your textbook and do that. And again, I apologize about the data camp. I also apologize for going over time here. And I will give you updates as soon as I hear back from data camp there. Okay, we'll end here. Thanks for sticking around. We will be back in person. I expect to be back in person next week. So we will see you next week. Have a great weekend.
Thank you.